Yeah, let's just check that sound's coming through. Double check. Double check. Alright, we've got the timer. And it goes. Okay. Tonight's going to be a bit of a funny one because I don't know if you can tell from the setup, but I've got a bit of a different setup now. Slightly different. I just got a new piece of equipment on board. So let's check how's that look. It looks alright. It's not perfect because there's some light being blocked by what it is I'm using, like, and stuff. So and hopefully I mean, check the picture actually, like, but I don't think anything stands out on the screen. It's like a little bit of shadow, but it's not too bad. Yeah, so I got some addition to my setup, but I've got a very tiny setup here, so I don't have a lot of space. So it's a bit of a squeeze for like what I'm getting done at the minute. But for people who are interested, I am getting. I have got a new Linux laptop I'm ready to set up. So next week, I think at some point, I'm going to. I think I'm going to do one of the stream nights as setting up Linux laptop, and that'll basically solve one of the problems I have at the minute with like too many things. I can't like see everything at the same time and whatnot and stuff. So it's not. Doesn't really matter to you guys, but I just thought I'd let you know. Maybe you want to join a stream for that. That'd be kind of fun. Building that. Setting up a Linux laptop from scratch, that'd be kind of cool. So tonight we are going to be getting through module. What number are we on now? Didn't say on it actually. Build a book bot. I thought I did all that. Maybe I got updated. But anyway, build the Asteroids one. I wonder why it's not saying that. But anyway, build Asteroids. And we're going to see how far we get. And we're going to go again on Thursday night. Thursday night? Yeah, Thursday night. We're going to go on build Asteroids again if we don't get through it in one crack. So we'll just get into it. Get started. Cool. Right. Building Asteroids. Let's get started. Start the course. Cool. So, build an Asteroids game. We're going to build a simple video game based on the classic Asteroids. If you've never played before, you can take a look at this, slightly different from our version of the game. Prerequisites: Python 3.1 plus installed. See the book.bot project for help if you don't already have it. Access to Unix-like shell, ZSH or Bash. Learning goals: the learning goals of this project are introduce you to multi-file Python projects, show you real-world use case for object-oriented programming, to have a ton of fun building a rewarding project. The goal is not to teach you game development or math required for physics simulations. As a result, there are some places where you will simply copy-paste code that we wrote for you. Don't worry about trying to understand every detail if it's not interesting to you. You'll be asked to write parts that matter the most. Assignment: get started by making sure you have the Boot.dev CLI installed and working. We're going to submit the tests using the CLI. Okay, so let's get our thing up. Okay, so where are we? Hold on. Get to the right folder. Okay, we're here. So we've got a thing. So we're going to copy this. Ooh. Okay. And copy this. Bingo. Right, so installation. We're going to be using Pygame and a virtual environment to develop our game. Pygame is a module for developing games in Python. It provides simple functions and methods for us to easily draw images within a GUI window and handle user input. Virtual environment, VM. Virtual environments are Python's way to keep dependencies, the Pygame module, separated from other projects on our machine. For example, we need Pygame version 2 for this project, but another game on your computer might require version 1. As best practice, each Python project on your machine should have its own virtual environment to keep them isolated from each other. Create a new directory and Git repository for this project somewhere on your computer. I guess, what should we call it? I think we just make it mkdir asteroids. Okay. And then create a virtual environment at the top level of your project root directory. Run this command. Okay, so because ensure pip is not available on Debian Ubuntu system, you need to install Python VM. Okay. We need to see that command after. Ooh. Uh-oh. That's a good start. What's wrong with that? For report. I have to Google this. What's wrong? There we go. Okay, we did that. So if we run this again. Oh, taking its time. Must be doing something. I just realized you can't really see what I'm doing here because my terminal is in the way like that. Hold on. This might be a better layout for today anyway then. Well, that took a while, didn't it? blimey. Anyway, so we ran that was no probs, and then activate the virtual environment, so source. Oh, I've seen this before. You should activate the virtual environment. So source VM bin activate. You should see VM at the beginning of your terminal prompt. For example, mine is like that. VM blah blah blah. Yeah. Make sure your virtual environment is activated when running the game or using Boot.dev CLI. Create a file called requirements.txt. So code requirements.txt. Okay, in the top level of your project file, add the following. So, whoops, and requirements. Okay, this tells Python that the project requires Pygame version 2.6.1. Install requirements, so pip install that. So you do that. Pip is Python's package manager. It will install the Pygame module into the virtual environment you created. Make sure Pygame is installed like that. Whoops, did that? How'd that get pasted completely wrong? Anyway, that again. And then make sure Pygame is installed. Note this will result in an error. The test expects exit code of 1, but the output will be shown as Pygame is installed. Okay, I think that's running. Run the and submit the CLI test. So that. Okay. Run this. Yay! Yippee! So it's 3 chapters: Pygame, Player, and Asteroids. So okay, we're almost done with the first part. Might get through this tonight then. You never know. Pygame. Now that we have Pygame installed, let's write just a bit of boilerplate code so that we have a runnable program to build on. Create a new file called main.py. So nvim main.py. On the first line, import Pygame. This allows us to use code from the open source Pygame library throughout this file. Just do this. Insert that. Write the main function that simply returns. Write a main function that simply prints starting asteroid. Use the exact text. Here we go again. Add this if statement at the end of the file. Is it func? So func main like that. Println like that. Was it? It's just print, isn't it? In a whoops. In Python like that. Whoops. This line ensures that main function is only called when this file is run directly. It won't run if it's employed as a module. It's considered the Pythonic way to structure an executable program in Python. Technically, the program will work fine by just calling main, but you might get an angry letter from Guido van Rossum if you don't. Run the program Python py. Nah, I bet I've forgotten the syntax already. Yep, I forgot the syntax already. Or I forget, what was the thing? Wasn't that, it was define main like that. I really need tmux, don't I? Okay. Okie dokie. Nice and easy. Next one. Ooh, this is going to get a little bit interesting. 8 chapters on this one. Surprised it's only as long as this. Only three chapters. And we're going to go through 8 steps, and then a final one with the asteroids. So I guess this is a very beginner-friendly thing and stuff. So if we get through this tonight, I think I might call it a day and get this laptop out, and we do that next time maybe. Try and get this set up so I can actually see my screen. All this side of the screen I can't kind of like really see right now because my thing is blocking it and stuff, so just need to sort that out. But anyway, let's see how far we get. It would be a massive pain if we had to fit all of our code into a single file. Importing. In Python, each .py file is a module, and we can import functions, variables, and classes from one module into another using the import statement. The name of the module is the file name without the py extension. So import the connect database function and database version variable from database py into the current file. If you want to import everything from a module, you can use the asterisk character. However, it's generally recommended to avoid wildcard imports as they make your code hard to read and debug. You can read more about this Python style guide. Constants. Games often have a lot of magic numbers to represent things like player speeds, item costs, and attack damage. We'll use this file as a place to store those kinds of constant values. Create a new file in your project called constants.py in the same folder as main.py and paste in this. Okay, so mvim constants.py. Okay, import everything from the constants.py into the main file. So mvim main. So it's from constants import all. and then print out the screen width and screen height values when main.py is run using the following format, like that. So okay. So print was it F, like that, print F. Let me call it this, something like that. And then it was screen underscore width, like that, something like that. F string. Oh god, I'm struggling with Vim. Print. I'm just going to do it the lazy way. Print F. That's going to be screen height. What did I do wrong there? Could try that. Happy days. So game loop. Okay. Video games are generally built using a game loop. The simplest game loop has three steps: check for player inputs, update the game world, draw the game to the screen. To create a good user experience, these three steps need to happen many times per second. Assignment import Pygame at the top of your main.py file. The Pygame documentation was super useful throughout this project. Initialize Pygame at the beginning of your main function. Take a look at the docs for the syntax. Ensure our predefined constants main.py. Constants.py screen width and screen height imported at the top of your file from constants like that. Okay, so Vim main. Yep, so it's already imported. Initialize the thing in your main, so initialize py Pygame init. Okay, that's way more doable for me. So, Pygame.init. Oh, I don't know how to. I don't know how to highlight rows. Oh, I'm so trapped. Right, hold on. Neo select line. By game.init. You sure your constants are in there? Yeah, we've already done that. No, because this small project and we don't want risking point file names, we're going to use a wildcard import for convenience, blah blah blah. Use pyname's display set mode to get a new GUI window, so like this. Create the game loop. For now, we'll only worry about step 3, drawing the game onto the screen. Use an infinite while loop for the game loop. At each iteration, it should use the screen's fill method to fill the screen with a solid black color. Okay, while infinite loop. So I've forgotten all syntax as well. So while, can't remember while. Forgotten. Python while. Geek for geeks. While. I mean, while you can just do while true, or can you just do that? Like, create the game. We now only worry about sort of 3, so use the fill method to fill the black color. So fill the surface with a solid color. By game surface can't type surface dot fill. Gonna be 0, 0, 0. Use Pygame's display flip method to refresh the screen, but be sure to call this last. Okay. So then, oops. Pygame display dot flip. It's a good idea to run and test your game frequently, so your code to make sure it's working as expected. If you're on a Mac, wait at least step 8 to do this. So yeah, I suppose you can't do it like that. Is that valid? Whoops. That's the fill method. What am I missing for the fill method? Color. Rectangle none. Color top. Window. Screen. Color, rectangle, special flags. Woohoo, it works. How do I stop it? Okay, I think it's running. We should see a black window and stay open. Close the game and kill program control C. Add the following codes at the beginning of each iteration of the game loop. So for each event in the game, event in the py event dot get. If event type pygame.quit, return. The following to the beginning of each iteration of the game loop. It will check for if the users close the window and exit the game loop. If they do, it will make the Windows close button work. Create a get ignore file with the following. So mvim .get ignore. Okay. Make a git commit. It's a good idea to make your progress whenever you're working on anything. So I think you did this yet, so get in it. Yeah, so let me just have a look. Slash git status. Do you want to thingy py cache? Yeah, that. Git ignore. Git commit. Ignore Python stuff. I'm just adding stuff. I know you probably guys can't see and stuff, but I'm just adding things at the minute. So git commit, adding basic stuff. They're not listening to the gig, no. Like, cat. Oh. What? Oh my goodness, what is up with the copy and paste? There we go, finally. Okay, I'm done with this step. Here's our next part. Whoops. So right now our game is redrawing the last screen as fast as it possibly can. Let's move this back this way and like that way. As fast as it possibly can. Can this cause it to use more CPU than actually needs? Delta time. In math, the Greek letter delta the Greek letter delta is often used to represent a change in a value. In game development, we use delta time to represent the amount of time that has passed since the last frame was drawn. This value is used to decouple the game's speed from the speed it's being drawn to the screen. Let me read that again. In math, the Greek letter delta is often used to represent a change in value. In game development, we use delta time to represent the amount of time that has passed since the last frame was drawn. This value is useful to decouple the game speed from the speed it's being drawn to the screen. If your compute speeds up, the asteroids shouldn't also speed up. Conversely, if your compute slows down, the asteroids shouldn't also slow down. They would just move less smoothly. FPS stands for frames per second. We're going to restrict our game to draw a maximum of 60 times per second or 60 FPS. After initializing a Pygame, but before the game loop starts, create a new PyGameTime.clock object. A DT variable set to 0. Okay, so endvim main. It's over here. So we do Pygame time. So we're going to call this clock equals that. And then a DT variable set to DT 0. At the end of each iteration of the game loop, call the tick method and pass it 60. It will pause the game loop until 1/60th of a second passed. End of each. Tick 60. The .tick method also returns the amount of time that's passed since the last time it was called, the delta time. Divide the return value. Also returns the amount of time that's passed since the last time it was called, the delta time. Divide the return value by 1000, convert it to milliseconds, seconds, and save it into the dt variable we created earlier. We're not using dt yet, but we will later. So okay, so then dt equals there we do. Oh my goodness. Expect an indented block after if statement on line 14. Okay. All right. Okay. Hold on. We're gonna do it on the clock, right? Now. So type error descriptor tick for pygame.time.clock objects doesn't apply to an int object. Okie doke, and it can be closed. Huzzah. If you're in the game, you should still see a black screen this time. Yeah, we did that. Cool, we did that. So now we're on to sprites. Note, throughout this project we will provide some of the code for you, like the class below. We want you to focus on specific parts and have pre-written the stuff that isn't related to the concepts we're trying to teach. In Pygame, there is a base class called Sprite to represent visual objects. Squid out long. Assignment. In our game, asteroids are visually represented as circles and the player as a triangle. However, detecting collisions between circles and triangles is hard. To avoid this problem, we can cheat a little bit. The player will secretly have a circle. The red circle won't be visible in the game. Only we need to know it exists. Let's create a circle shape class that inherits from Sprite to represent objects in our game that are treated as circles, even if they aren't. Create a new circles shape.py and paste in the following code. Please do it properly. Okay. Circle shape extends the sprite class. So look what it's doing. So circle shape, give it a sprite. Our self subclasses must override. Circle shape extends the sprite class to also store a position, velocity, and radius. Later, you'll write subclasses of circle shape and override the draw and update methods with the logic for that particular game object. Run the CLI test from the tool. See what it does. Okay. What's happy days? Happy days. Okay. Let's draw a spaceship for the player. Add this line to constants to define the size of a player's ship. So name constants. Create a new file called player.py with the player class that inherits from circle shape. Okay, so then vim player.py with the player class inherits from the circle shape. So it's going to be from, oops, I keep always forgetting that. So from, what was it called? Circle shape. Select. Oh no, it's import. Import circle shape. Circle shape. Class. Now I've already forgotten how the class goes, so hold on. Cat circle. This is going to be, it goes full screen so I can see properly. So player, it's going to be circle shape. Whoops, you get used to NeoVim. Circle shape. The player constructor should take X and Y integers as input, then call the parents class constructor, also passing in player radius. Create a field called rotation initialization to 0. I don't think we need that. Whoops. Oof. That's close. And then we said call parents class constructor, also passing player radius. I forgot how to do that already. Create a field called rotation slide to 0. So self. Self rotation equals 0. What was it? How did I do it again? Boots. Parents. Class. Inheritance is a feature, blah, 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 blah. So, so methods of parent class. This promotes code reuse and also helps prevent redundancy, adhering to the dry code, blah, blah, blah. The super function is used to call parents classes constructors. Okay, I remember that. So this is not going to be this. It's going to be, whoops. What was it? Y and X and Y. X, Y. Integers as inputs, then call the parents class structure, create field called rotation 0. Okay, so and there. Self dot X equals X, and then self dot Y equals, oops, equals Y. Call the parents constructor, also passing the player radius. Player radius. So, what was it from? Constants, import this, and then we want that, like that. Paste this triangle method into your player class. That's a better way of doing this, and you get used to any of them. I think that's it. I We got anything? No, not yet, but it didn't crash, so it must be fine code-wise. I suppose it's not calling it yet, is it? So a player will look like a triangle even though we use the circle to represent its hitbox. The math of drawing a triangle can be a bit fiddly, so we've written the method for you. To draw the player, override the draw method, use a draw method of circle shape. It should take the screen object as a parameter and call pygame. To draw a player, override the draw method of the circle shape. It should take the screen object as a parameter and call pygame.program takes screen object. A color, use white. A list of points, use self.triangle we provided for you, and line width, use 2. Okay, update the draw. Draw players, oops. Pygame.draw. Also draw a polygon. It takes a screen object, so where do we have the screen? Self.screen. Use color, a color, use white, so I'll use 255, 255, 255. The list of points, use self.triangle we provided for you, so self.triangle. Then width, use 2. In your main function instantiate a player object, you can pass these values to the constructor spawn it in the middle of the screen. Okay, so look at that, and then vim main. Then so player equals new player. Lastly, we need to re-render the player on the screen each frame, meaning inside our game will use the player.draw method we use to do so. So x, y. And we needed from player, import player. See what the thing is. Not quite. So let me see quite parameters. Y in radius, so init main player. Main. Figure out why it's doing that. Whoops. I don't know if it worked or not. No, not quite. No triangle in the middle, so I'm missing something. Hmm. Hmm. To figure out why I got myself into that sticky situation with that. Hmm. Let me look at this. Where's this coming from? Pygame draw.polygon. Anything? Nope. What am I missing? Screen object. Screen object. Read the draw method. Whoops, I did in the completely wrong spot, that's why. Hold on. Vim, copy, and paste. Paste. Line. Okay, so and then Pete. Ah, no. Player has an object of attribute screen. I need to fix that. Almost. Pygame surface.surface has no object draw. Almost. Screen.draw.polygon, you pass it the screen. Pygame. Hold on, maybe it was right. Almost. It's almost there, come on. surface color points width. Screen that we pass it, color, self triangle 2. Maybe this isn't. No, it should be done properly. That is super. What am I missing? Just slightly off. Yeah. Not quite sure what's wrong with this one. I'm going to ask for the solution files. Oh, seer stone. Hold on. Give me a tip first. Draw a player after filling black screen. Oh, before flipping the screen. Right. This could be it then. Main. There we go. Huzzah. We got one. Okay, we did that. I'm done next with this step. Yay! Moving around. Moving and groups. We want spaceship to be able to move, but what does it specifically mean? What does it that mean specifically? Let's break it down. If we press the move left key, the ship should rotate to the left. If we press the move right key, the ship should rotate to the right. If we press the move forward key, the ship should move forward. If we press the move backward key, the ship should move backward. Left and right seem pretty similar. Let's try and write a small function to tackle those first. So create a new constants in the constants.py to represent the player's turn speed. I name mine player turn speed and gave a value of 300. So constants. 300. Okay, actually now we're on to a new section. Get this. Get all. Commit. Should we say chapter 5 done? Chapter 5 done. Okay, add a new method to the player class called rotate. It's going to say one argument dt. I told you we use it. When it's called, it should add player turn speed times dt to the player's current rotation. Okay, let's do that. So nvim player. Oh, I need to fix that somehow. Where the hell that is? Rotate. Okay. I need to press it. Rotate. Oh, okay. Rotate. DT. When it's called, it should add player turn speed times dt to the player's current rotation. So self dot rotation equals that. Paste in the following update method in the player class. Now, if you use a non-QWERTY keyboard, you may want to change the key bindings in the code to something other than WASD. Update the missing lines to call rotate method with the DT argument. Go left instead of right when A is pressed. When you need reverse D to reverse DT, how can you do that? Okay. So this. Pygames key A. Alright, so left. So it's going to be self.rotate. It takes dt. So self.rotate and then minus dt like that. I don't know if I can do that. Update the missing lines code, rotate message, blah, 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 blah. Tried that. Update, hook the update method into the game loop by calling it on the player object each frame before rendering. So main.nvim main.py to the game loop by calling the player each frame before rendering. Update. Oh, whoops. And dt. Not really doing anything, is it? Oh wait, hold on. Oh no, didn't work. Play turn speed is not defined. Whoops. So player 8 RSTUD, so player turn Didn't quite work. Each frame before rendering. Oh, hold on. It sort of moves, but doesn't. It does, but it doesn't. Hmm. I mean, to be honest, I think the answer is just to lift this out. Like, this comes out of the loop. It is, but it's not. Not actually turning them all the way around till it. Hmm. Sort of does, but doesn't. Yeah. Why is it not turn? It turns once and then it stops. See, it turns a little bit, but then it just doesn't do anything after that. Might need to accept help on this one just to get through, because what's wrong with it? Let's go through it again. Yes, add a new method called rotate. We did that. Paste in the following update method, use apply things, so like keys and blah blah. Fill in the blanks, so update the missing lines to call rotate method on the DT argument. Go left instead of right. When A is pressed, you'll need to reverse DT. How can you do that? Hook update method into the game loop by calling it on player object each frame before rendering. So have a look. I'm going to confirm it because plus equals right. Okay. One thing is this. Player. Yep. There we go. Now, instead of rotating, we need the ship to move back and forth with W and S keys. Assignment: create a new constant and constants PY to represent the player speed. Player speed, I gave it a value of 200, so nvim constants. Add a new method to the player class called move. It takes one argument DT. We want to modify the player's position, but first we need to do a little bit of math. Okay, one step at a time. So nvim player, and we want to add move. Move self and DT. First we start the unit vector pointing straight up from 00 to 01 unit vector. Oh, okay. Don't need to think of what that is. We rotate the vector. Hold on. Oh my goodness. Guess I don't need to read that. Playing straight up from 0, 0 to 0, 1, we rotate that vector by the player's rotation, so it's pointing in the direction the player is facing. We multiply by play speed times dt. The larger vector means faster movement. Add the vector to our position to move the player. This is of course in programming, not vector math, so we've done the math for you. All those words boil down to these 2 lines of code. Forward equals pygame.vector this, rotate that, blah blah blah. Update the method, modify the update method of the player class to call move when method of W, S and keys are W or S keys are pressed. Okay, so the update method. So we're going to have a similar thing of if keys and then pygame dot key underscore W or S. So W forward. W self dot move delta. And then if keys pygame dot key underscore S, was it? S equals self dot move. That's the delta. Whoops, not quite. Oh yeah, I didn't modify the thing. So we're going to import player speed. Try that again. Ooh. That's cool. There we go. It works. Easy. That was an easy one. I'm done with this step. Last step in this one in chapter. Oh, I keep forgetting things, so hold on. Git add. That's all. I need to make a better habit of this. I'm going along. I'm not thinking it as a Git project. So finish. Finished lessons 5 to 8 in chapter 2. Silly me. It's the last one. Groups. We currently manually call update and draw on the player object, which means our game loop is going to get more and more cluttered as we add additional objects to the game. Fortunately, Pygame has a solution. The group class is a container that holds and manages multiple game objects. We can organize our objects into various groups to track them more easily. You can think of them as a sort of Venn diagram. An object can be in multiple groups at the same time. Eventually, our games groups will look something like this. So updatable asteroid field, player, asteroid, asteroids, stroll. Creating and using groups. Okay, drawable, asteroid field. We can create groups Creating and using groups. You can create a new empty group like this. My group, pygame.sprite.group. To add all instances of play to two groups, group A, group B. In this example, we add a class variable or static field called containers to the class, just like so. With literally this one line, you don't need to bother with adding this field to the class declaration. After changing a static field like containers, make sure to create all player objects after the change. This way they will be correctly added to the groups. You can iterate over objects in a group just like in any other collection in Python. So for thing in group thing.do something value. You may also call update method for every member of a group by calling it on the group itself. So group.update dt. Assignment: before the game loop starts, create two groups in main.py. Updatable, all objects that can be updated. Drawable, all objects that can be drawn. Let's copy the syntax. So in main.py, so mv main.py. Groups, so both groups as containers for the player. Updatable. So update able. Updatable equals that. And then drawable, drawable that as well. So made two groups like that. Set both groups as containers for the player. Set both groups as containers for the player. Set both groups as containers for the player. I think that's right. Change the game loop to use the new groups instead of player object directly. Call the update method on the updatables group and loop over all the draw objects and draw them individually. Okay. So it's going to be dates double. Update. Put that in. Double. Trouble. D. drawable thing equals drawable thing draw. Green. Not quite working. No, not quite. Group.update. Updatable.update. Loop over all the drawables and draw them individually. Come on, let's get past this one. What's the dealio? Oh. I don't put it on the instance, I put it on the whole thing. Right, okay, that wasn't... Okay, that didn't quite make sense to me, but it's what it is. And There we go. Just a misunderstanding. Done with this step. How many are in here? 7. Is that... Yeah, you know what? I might leave it tonight. Don't think we get into this now. It's going to get into bedraggled arena. But anyway, we got a pretty far. I think we'll be able to finish this off tomorrow night. I'm gonna stick on time. I don't want to like go over by loads. It's not healthy. Brian Johnson's gonna. I'm not going to stay up past my bedtime, otherwise Brian Johnson's going to tell me off. So that'll be it for tonight. Got through a decent amount. It was pretty interesting, pretty fun. Had to use some of the cards a little bit too soon, but it doesn't matter. It's only the first project and stuff, and it's pretty basic. I've got 7 lessons left on the asteroid thing. We can definitely do that. Like, we can definitely get that out, like on Thursday night. No probs. Not going to be that difficult. And I guess that is all for now. So, yeah, good night to you all. Thanks for coming down to watch. Hope you had a good time, learned something. If you're coming in from the future, thanks for travelling back, and see you next time. Ciao.